Good afternoon, ladies and gentlemen of the two honors. We have the people who are supposed to be here, except for Luke. Hope he's okay. What we're going to do here today is continue solving graphically, then check your solutions algebraically in this set. And so, what was the procedure we had for solving these graphically yesterday? You remember what that was?
We put them in the paper,
Yeah.
and then
On the window.
Yeah, so basically, I'm hearing two things. I heard something from a couple different
we
people,
also need to put a second 5 and turn to actual.
and so that's even the technique Steve was getting to. Okay, so we have 5e to the negative 3x, and I heard Jace, amidst the cacophony of answers there, Jace was saying about adjusting the window. And what would be the timing of adjusting the window versus putting these in the calculator? What would the timing of those be? My answer would be, normally I'd put the equations in first. And sometimes, after putting in first, you can just hit graph, except if I really know what the window should look like, then I go directly to the window. But yeah, all of you said some good things here. And so let's clear out here. So we have 10e to the 6x, 5e to the negative 3x.
Does it say solve algebra correctly though?
No, it does not. And I'm going to kind of explain what that is. Yeah, 5.
Okay.
No, that's fine, but Steve, you're making a good point, to the power of negative 3x. And what happened is, if I don't have any really good handle or really good idea about what a good window is, I usually resort to a standard window. And how do you get a standard window? Press zoom 6. So I press zoom 6, and really, that was probably a good move, right? Because we can see pretty well the intersection. Oh man, that's right. How did you know I was getting hungry? How did you know?
I just read your mind.
All right, very good. Man, you guys are really awesome.
Sorry.
Actually, I've been seeing these things, and what happens is this is
Teacher appreciation week.
well, actually, it's a week. It's after appreciation week. But what happens is,
You get another one, Mr. G.
yeah, this is like the laggard. I saw these things
They should love you,
out
Mr. G.
in the room like last week, and so I guess they just waited to get it. Now last week, if your goal working last week, at least being a teacher, was to lose weight, it was the wrong week for it. With all that food they were having and all that, my gosh, I did gain weight. But I'm back on track. I am back on track after weekend. So anyway,
You trying to lose weight, Mr. G?
second trace 5. Yes, I am a little bit. Enter, enter, enter. And so we got negative 0.077, right? So x equals negative 0.077. Now I appreciate that who was it that said, yeah, check algebraically. Now the way the book did it, what the book did is they suggested just taking these numbers and substituting back in for x. And that's not my preferred way of doing it. My preferred way of doing it is to just solve algebraically and test by that. So I want to go through it because it kind of reviews some of the properties of logarithms and so forth that it takes to do that. So I'm going to just write here 10 e to the 6x power equals 5 e to the negative 3x power. What's going to be a first step in solving this equation, do you think?
Dividing by 5?
Yeah, I would divide by 5. I think that's a good first move right here, right? So if we divide by 5, what do we have left? So we have 2 e to the 6x equals e to the negative 3x.
Then you want to do something log. Like, I think what the point is, Ln, because it would be
Yeah.
e to the e, so.
Yeah, so Steve-O was saying he thinks ln because ln is log base e. And yeah, I'm with Steve-O on that. So what I'm going to do is I'm going to put ln of this right here. And then on the right, I'm going to take ln of e to the negative 3x. Okay? So that was really a good first move. What next? Or actually second move.
You would lose the negative 3x and the 6x in front.
Yeah, now I want to show you something here. I want you to do one thing before that. Okay, now you could do that and kind of see where that gets you. And I guess ultimately that would get you to an okay position. But the way to do this, I think, best way to do this is to write this as ln of 2 plus ln e to the 6x equals ln e to the negative 3x. Okay, you see what I did and how I did it and what rule allowed me to do it? Okay? Right, because the multiplication, it's the product property of logarithms. If you have two numbers that are factors, those two numbers can be those logarithms of each of those factors added together. So that's what it is. And so now, what can we do?
Put the 6x and negative 3x in front.
Yeah, so we can do that, the negative 6x. So we're going to put, I'm going to put ln 2 plus 6x ln e equals negative 3x ln e. What happens to ln of e?
It punches opposites.
Yeah,
It
so,
becomes a 1.
yeah, it becomes 1. I want to show you that. I want to just show you that here. ln of e, okay, should be 1, right? So these things reduce to 1. So if these reduce to 1, now what we have is ln of 2 equals 6x, plus 6x equals negative 3x. What next?
You probably just subtract 6x.
Yeah, so
And so it could just be on
Yeah.
one side.
So what I have here is ln of 2 equals negative 9x. And so therefore, x is equal to ln 2 over 9. And so you can take ln 2 over negative 9, excuse me, I got that wrong. ln 2 over negative 9. So ln of 2 over negative 9. And so we get, does that look familiar? Yeah. Now I think, again, negative 0.077. Again, what I think the textbook writers are saying is we're still solving graphically, but we want to also kind of transition into being able to solve these algebraically as well. And so you confirm what you found graphically. Okay? Questions on that one?
No, sir.
All right, what I want you to do is look at number 5. I think it's a similar sort of a thing. And I want to choose somebody to help us solve number 5. So we are right here. So I want you to try to set that up graphically, and then we'll try to confirm algebraically also, okay? Good. Okay, this one today, Bailey is the drawer of the short straw on this one. So what, have you been able to work on this here?
That's what I want to write to, but I can't figure out the one.
Okay, let's go ahead and have what you got so far. What'd you get?
0.
So how did you look at it first? Where are you on this?
So y1 I did 450e to 0.4x.
450e to the power of 0.4x, okay. And this other one is y2 equals 2,000, did you say?
Mm-hmm.
So I had 450e to the power of, you say 0.4x? Oops. How do I get up there? So 0.4x, that's it, isn't it? And this other one here is 2,000, you said? And then what did you do? What did you do next after this?
I did the window, but I still haven't gotten it.
I have the window.
Yeah. Now one thing you can do, it never hurts to do it, is just press graph, because it could be that you already have a good window, right?
Mm-hmm.
Do we have a good window here?
No.
Not that we can see, right?
No.
So what do you think, Bailey? What did you choose for your window here?
Negative 50 to 25.
So negative 50 to 25 here. Okay, and then you can, I'm going to X scale 10. Okay, and then?
And then for my scale, I did 1.
1, okay, 1 right here. Okay, all right.
And then for my y min, I did 0.
0, okay.
And then for my y max, I did 2100.
2100? Okay, good. That looks kind of familiar from second period. Then just graph and see what it looks like here. Now, but before pressing enter, is there some number in here that would give you some kind of comfort or confidence level that maybe you'll get an intersection point out of this?
The 2100.
Yeah, that's what I'm, okay, she said the 2100, that's kind of what I'm thinking, because you have that 2000, and we know that's a higher than that. So yeah, that's what I'd say. And so we have, so that looks okay, doesn't it? So then we can go, what, second trace, 5, enter, enter, enter. So 3.729. So x equals 3.729.
My graph was definitely different.
It looked different, right?
Yeah.
Mainly because the
Part of it was 0.5 for X and 0.2500 for Y.
okay, yeah, right. So you had the different windows, essentially. Okay, and now we have, and I'll tell you in second period, I think that they used the Y, on the window, they used a Y max of 2000. It worked out, okay? It came, the line was right at the top, still worked. You could see it. I mean, not as well, I don't think, as you can see this one here, but still pretty good. Okay, and then solving this thing algebraically, if we have 450 e to the 0.4x equals 2000, how are you going to solve that one algebraically?
Divide it by 450, right, to get you by itself.
Divide by 450, okay. I'm with you there. So we have e to the 0.4x equals, and I can cut off these zeros. So what is this going to be as a reduced fraction here?
4.4444.
Okay, that's that decimal version, but we'll say 4.444. We'll do that, right? Because that'll give us a lot of, you can get a fraction, but I think this is a good way to go, really, to put a lot of decimal places to it. Okay, and then what?
For the next thing, we put the ln. Do ln.
Yeah, so the next thing I would do is I'd say ln of e to the 0.4x equals natural logarithm of 4.444, right? Does that make sense? Okay, then what happens next? Okay, what can you do is 0.4x, bring it out front, right? So 0.4x times ln e equals ln 4.444. Now anytime you see ln e, you should be thinking ding, 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 ding. What? It's just 1, right? Ding, 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 ding. Cross it out. So now we have 0.4x equals ln of 4.444, and then what next? Solve. Yeah, so if we divide by 0.4, so x is going to be equal to
3.7.
we go ln 4.444. Oops, I went to the wrong place. ln 4.444 divided by 0.4, and we get 3.729. Same, right?
Yeah.
Now, one thing that you did better than the person second period did was you went out some decimal places on that 4.444. I think the person second period just went to 4.4, and what happened is the answers they looked pretty close, but not as exactly close as this. So when you are solving something in the process of, and you haven't quite finished the problem yet, that's not the time to round off. Time to round off is at the very end,
Yeah.
after you've made all your calculations.
I don't think what should number six.
All right, thank you, that was really good.
I found X on number 6, but I don't do the, like, solve it algebraically.
Okay,
I know,
we'll see here.
yeah.
Yeah, that's fine. If you don't know how to do that, that's fine. Part of it is the way they have it. They have the scaffold that is for you. We'll work on that together if we need to.
I have that.
You have that too? Okay, well then Steve-O can help with that if we come to it. Okay, that's good. Yeah, so this here is fractions. And we know that just historically fractions are really loved by people around the world. Yes? No?
No.
No, okay. Yeah, I wanted you to say no.
Mainly one thought goes on and on forever. Two thoughts.
So it just so happens that we chose Victoria on this one. There was this she was asking about. So that's really good. She's been working on it. She's been working on it. So that's really good work. Okay, let's go here, Victoria. What do we have?
So I plugged both of them into the right pools.
Okay, so let's just go to the calculator. 500e to the 1/3. So 500e to the power of, we'll say 1/3, was that it? Yeah, I'm gonna go, I'll just set it up like this. I don't have to, 1/3. Okay, and then the other one was it 225? 225?
You forgot the X.
Oh, X, oh, thank you for reminding me of that, my gosh. If I forget that, I'm just gonna have a flat line.
Yeah.
Yeah, thanks for reminding me, okay. Now back here to 225, right? E to the power of, was it 2/3 X?
Yes.
Okay. This time, I'm not going to forget the X. Okay, so we have this, and we have a window already. So I'm just going to say, hey, might as well just graph and see what happens, right?
Yeah, with the window already, it works.
Okay.
That's what I kept.
It did not work for me.
Didn't work for you? It may be a little hard to see that it does work. I mean, it does work. And you can, if you tighten up the X's, you'll be able to see better. So I just want to tighten that up to see better here. Okay, -5, 10. Yeah, so you can see better, but in either case, you'd still have your intersection point, right? All right, so second trace 5, enter, enter, enter. So is that what you got, Victoria?
Yes.
2.396 maybe?
And I don't know how to do it the other way, so Steve said I have to do that, but I did check it the way that you said the book did, and it worked.
Okay.
Yeah, so you check by substituting in, okay.
Well, what I did, while I was doing graphically, was I wrote that one out first.
What did you do first?
I divided 225 by 500. I mean,
Like this?
no, I did.
Or you did it the other way?
Yeah, because
Okay.
instead of doing like 2.222 discontinuity, I just got 0.45, so I don't have to deal with it going on forever.
So you're saying by doing it this way, you got an easier number to work with?
Yes.
Okay, well that's a cool way to look at it. So this comes out, right?
Yeah, it becomes 0.45.
So e to the 1/3 x equals 0.45,
Yeah.
e to the 2/3 x.
Next, you would put in log.
So you put ln on it,
Yeah, ln, yeah, that's what I meant, yeah.
ln,
And I also separated 0.45 by e, so it'll be ln 0.45 and ln e to 2/3 x.
so on the right side, here you got ln e to the 1/3 x
Yeah,
equals ln of 0.45
yeah. And then-
plus ln of e to the 2/3 x,
Yes.
okay?
And then you move the 2/3 and 1/3 in front of it.
So what you get is 1/3 x ln e equals ln of 0.45 plus 2/3 of
ln e.
ln e.
Then the ln e's cancel out.
So ln e's will go away here.
Then I subtracted by 2/3.
Well, that's, I forgot x there, right?
Yeah, that's subtracted by 2/3 x, and I got negative 1/3 x. on
So you
the
subtract 2/3 x,
Yeah.
so those will go away. So I'm going to come up here now. So we have, in the left now, you have negative 1/3 x
Equals ln of 0.45.
equals ln of 0.45.
So the x equals ln and 0.45 over negative 1/3. And when you put that in the calculator, you get 2139.
So the same thing, right? Okay, very good. 2.396. Okay, did you see what I did here? Instead of dividing by 1/3? Did you see what I did there? What did I do? I multiplied by 3, by negative 3. Multiplied by negative 3. Okay, I want you to look at that next one here, number 7. And number 7 is another set of instructions. If I'm not mistaken. Are the properties of logarithms kind of gradually becoming more familiar to you? I'm getting some sense that they are, right? Just getting, I mean, it's just getting some
Practice.
Yeah, this is some practice. We're getting some good practice here. Okay, so really what they're doing here is they're asking for a not algebraic thing. They don't say it in that word exactly, but really it's an algebraic thing, and so I want you to work on how. Are you working on that now? Have you been working on that, Ryan? Number 7. All right. Do that.
So do you think the first thing we should do is add 10 to both sides to get the 10?
Yes, I would, and that's the thing about it, all right? One thing that I've talked about in this class quite some time ago, and maybe you remember what I'm about to say, but I think that there was something, what you can do is you do something we call the onion method, right? That you put these little onion layers out here. And what you have is the way you solve is like the pearl that you're solving is in the center of the onion, right? And the first layer is what?
Negative.
Get rid of the 10. So if you add 10, so you get on the right side, negative 3 plus 10 is 7. So now we're left with 6 times to the power of 3x minus 9. Okay. Yeah, and then the 6, well, you deal with this thing, so. So Riley, do you have an idea on this one? Yeah. What have we done in all the other instances of the solving when we didn't graph?
Break it out.
Okay, what we do is we take a logarithm of both sides. We have log of this side, so log of 6 to the power of 3x minus 9
Log 7.
equals log of 7. Okay, what's going to happen next after this? You have 3x minus, come front, so we have 3x minus 9, we're going to bring that out in front, times log of 6, and that's equal to log 7. And then what? Okay, remember, let's go ahead and look at our onion again, right? So we're looking at this, solving for this. Then we got this layer here, right? Then we got this layer here, and then we got this layer here, right? So what are you going to do to get rid of this thing here? What is this log 6 doing to this other inside part of the onion?
Multiply.
It's multiplying. What
We divide.
divide. So we divide by log base 6. And so now we've done that, we've crossed that out. So now we have 3x minus 9 equals log 7 over log 6.
What he did it?
What'd you say?
What? I did it different. I made it log 6 of 6, so I just made it times out.
Oh, so you did a log base 6 operation?
Yeah.
Yeah, you could do that. I used the change of base formula, and that really tells you, one thing that tells you is that you do have options, that there's not, in these problems, one exact way to do it every time. And so that we have is, if we add 9, right? So we have 3x is equal to log 7 over log 6 plus 9. And then we have x is equal to log 7 over log 6 plus 9 divided by 3. And so we can go to the calculator. And here's where I find some challenges, because to enter all this right, alpha, I get this, I'm going to put another fraction up here. So log, I want to make sure I have this right here, log 7 over log 6 plus 9. Log 7 over log 6, and over here plus 9, and divide by 3, right? Is that it? Press that, so 3.362.
So I got 3.
Okay, good work. So that's it, and really we're out of class time today. We got a few more problems to do on this tomorrow, which is fine. Thank you, class, good job.